Thank you. Thank you, Mary and Christian, for your stories of patient advocacy and all of your work there. As mentioned, I'm Tom Lowry from T2, and what I'd like to speak today about is how a lot of the themes that we've been talking about with regard to antimicrobial resistance relate specifically to bloodstream infections and how diagnostics can play an important role in helping solve the problems that we face. I've been really inspired and energized by all the energy and the ideas here and the recent support and progress that we've had at T2 from government agencies, from our customers, and our product development processes. So I'm showing here a slide that describes the paradigm today for diagnosing and treating bloodstream infections. And one of the reasons why today patients are treated without knowing what they're infected with is because the diagnostic paradigm is so slow and has inherent challenges with sensitivity. It's based on blood culture. So we're all familiar with empiric therapy and the regimen that patients go through where that therapy gets changed even before there's any culture or diagnostic test result to help guide that therapy. Because of that, patients who get a blood culture drawn, about 60 to 70% of those patients are put on IV antibiotics, whereas only about 10% yield a positive blood culture. And of those that are actually infected, you have almost half of those patients are not on effective therapy. And that's staggering when you think about the amount of overtreatments occurring for bloodstream infections. It's because the problem is so severe that we're actually trying to get out ahead of it by using up our antibiotics in a very inefficient way. The good news is that once species identification comes back, resistance identification comes back, then the proportion of patients on effective therapy increases dramatically. And so the reason why this matters so much for bloodstream infections, and we've heard two excellent examples of that, is that it's a very acute situation where you need to get that patient on effective therapy rapidly. Every hour that passes when a patient has a bloodstream infection and they're not on effective therapy, their odds of death go up by 4%. Once you enter septic shock, that's up at 7 to 8% per hour. So this is a severely acute problem. You need to get them on effective therapy. Physicians are trying to do their best by guessing what therapy they should administer to the patient. And our mission at T2 is to help address that problem by providing definitive diagnostic information very, very early in the progression of disease to better inform that therapy choice. So an important theme for what we do at T2, and we still find ourselves having to explain this, particularly as we go and interface with the laboratories, is that we don't use a positive culture. So it's very ingrained in our system when we diagnose patients with bloodstream infections. You go to a blood culture bottle, you incubate that, and there's a lot of great technologies around getting that information out of a positive blood culture. What we do at T2 is we're direct from sample tests that can detect pathogens and resistance genes directly from a patient sample. And this has an inherent advantage in speed, but also sensitivity. The guidelines are very clear for cultures. You need to take 2 to 3 to 4 sets of blood culture to get to that 90 to 95% clinical sensitivity. That causes additional delay in time, some complications, because ideally a culture is required before the patient's on antibiotic therapy. So a lot of cultures are required after the patient's antibiotic therapy, which leads to false negatives. And then all of the innovation in what's quote-unquote rapid diagnostics outside of T2 Biosystems here in the United States has been on positive culture samples. And so those are your molecular tests, your MALDI, and so forth. So hospitals that use T2 Biosystems technology here in the United States, also around the world, have the advantage of being able to get results directly from that blood sample in a few hours. And I'm going to talk a bit about what that means in terms of the workflow in the hospital, but the advantage for the patients is that you can get your patients on effective therapy far earlier. I'm going to take you through some case studies that help demonstrate that as well. Something that we're very passionate about at T2 is that there's an opportunity here finally to go directly to the patient sample. So first I want to mention a Mal Weinstein quote at ID Week a few years ago. He called going direct from blood as the Holy Grail, and it's been pursued for many years, about 2 decades now. There's been a lot of technologies that have tried to do it. It is incredibly technically challenging. That's one of the reasons why so many technologies and companies have pursued this. Oftentimes they've pivoted to a post-culture test or moved out of the space altogether, or they've just stayed with the CE mark test. So we're the first tests that have gotten not only CE marked, but also FDA cleared and are in routine clinical use here in the United States. I'm going to take you through our pipeline and how we're expanding that. I'm going to tell you a little bit about the technical challenges for a direct from blood test. But what we keep running into over and over again, even as we go out and talk to hospitals, is people get us mixed up. They think, well, you're not a rapid diagnostic, you're not like the other rapid diagnostics. There's a big difference in the way these tests are used in terms of implementation and their actual potential clinical impact when you can go directly from that blood sample. So some of the technical challenges that we've had to face, we've been working on this for almost a decade now at T2, and number one is you have to have extreme analytical sensitivity. You have to be able to get down to that 1 CFU per ml. So a post-culture test, molecular diagnostic test, the limits of detection are about 2,000 CFU per ml to 1 million. So that's a very big difference in the regime. So even our positive controls that you run on our tests will yield a negative result on those molecular platforms. There's a big difference in analytical sensitivity, which presents a lot of other challenges. One of them happens to be getting high specificity. So you have to have, for a test like this, upwards well above 95% specificity in order to ensure that you're not detecting things that aren't associated with the infection. There's also a lot of interference in these patient samples, particularly when you're detecting direct from blood. And that's one of the things about our T2 reading, because it's magnetic resonance based, it's basically agnostic to those types of interference. And then as a company, you really have to be good at the microbiology. In order to develop a test like this, you have to make sure you're always working with viable cells, and you have to have sample stability and a variety of other characteristics to be able to robustly optimize the technology and then do clinical validation and, of course, verification. I'm not going to spend a lot of time on this. People that love to dive into data, I'm happy to talk to you afterwards. But if you go through and look at the analytical performance of technologies that have tried to go direct from blood and ones that have made it in terms of FDA clearance and haven't, there's a really important theme. And I've learned this also by working with the great folks at the FDA in the group that we work with, is that the analytical performance metrics now are very well understood and established that are necessary to get good clinical performance metrics. The clinical trials are now well defined. That's taken some time, but also some innovation on the regulator side, and then work from our end to help define that pathway. So it's a very clear pathway in terms of what you need to achieve in terms of analytical verification and then clinical validation. So how does the test work? So it's a fully automated test. You take the blood sample, you put it on the instrument. The instrument takes 2 mLs of blood. It lyses the red cells and concentrates all the debris into a pellet, including the intact pathogen cells. An important attribute of our test, and I think it's key to be able to get high specificity in this patient population, is that we select for intact pathogen cells. We don't detect circulating DNA. So that helps get rid of any signal that comes from your commensals that may be present, and that gives you a very high % agreement in terms of your specificity with blood culture. And then after that selection process, that goop that's left over that has your intact pathogen cells, a bunch of other debris from the human sample, it gets processed with an amplification step, and the amplified DNA product gets detected by our T2 magnetic resonance reader. The great thing is that actually in that amplification process and later on detection, there's a lot of debris. It's almost like a blood pudding. But those kind of matrix and that kind of things don't affect our signal because we're detecting a non-optical signal that's very much like MRI, but a miniaturized system. I'd love to talk more about it. People that know me know that I like to talk about it, but I'm going to hold back on giving a physics lesson. In terms of our menu, where are things at? So the first test that we got cleared was in 2014. That's T2 Canada for 5 species of Canada. And that created a new product code at the FDA. This was the first test of its type. And then in 2018, we got what's called the T2 bacteria panel. Probably a better name for that would be the T2 escape pathogen panel. So these are the escape pathogens, and the most likely pathogens that will not respond to the standard empiric antimicrobial therapies. That got FDA cleared. And then the next panel in the pipeline is T2 resistance. It has not been FDA cleared yet. It has what's called a breakthrough designation, which is a really nice process to enable a more efficient process through the FDA, and now has some benefits when it comes to CMS and NTAP, as we've heard yesterday. That detects resistance genes directly from the patient sample, once again, same kind of performance in terms of turnaround time and sensitivity. And these are the resistance genes that are listed by the CDC as the most concerning ones for bloodstream infections. We have a Canada aureus panel that's available. It's a research use only panel. There's several institutions outside the US that are now using this and stockpiling it for the outbreaks. It's used for patient surveillance. It's a nice paper that was published by the CDC using this panel. And then there's 2 other panels that are in development. Rick Bright mentioned us yesterday, one that's a comprehensive panel for all bacterial bloodstream pathogens, and then another one that's a biothreat detection panel, all with the same attributes in terms of sensitivity, specificity, and turnaround time. So one of the exciting things of this last year, and really boosted our confidence and the support that we're seeing from the US government, came from CMS. So about a year ago, we engaged in this new technology add-on payment process, or NTAP. It had never been given to a diagnostic before. We worked with the group there at the CMS through a fairly rigorous process of meeting with them, submitting written information, and then had a lot of customers and supporters provide information as well, and shared a body of clinical evidence that showed that the test was a clinical significant improvement over the standard of care. And that was the key thing that we had to demonstrate. We already had checked the box on newness. You have to have been FDA cleared within just a couple years to be eligible for NTAP. And then you have to have a patient population whose costs exceed the GRG. So unfortunately, or fortunately, patients that suffer from sepsis typically exceed the DRG. So we're really excited by the conclusion of CMS that this is indeed a substantial clinical improvement. And our customers and the laboratorians are very interested in this NTAP payment. That's something new for the laboratory to be able to look at that and use that to cost justify the use of a test. It covers 2/3 of the price of the test. So the other thing that was exciting for us, and through some advocacy from some of our customers and a great group at NHSN and CDC, looks like that slide has a timer on it, so we're going to go back. And we're going to have to go back more than once, so I'm going to talk long on this one. The guideline for CLABSI originally had included non-culture-based tests, and that basically meant that if you had a new technology that was better at detecting infections, you could get penalized as compared to your peer group as it relates to CLABSIs. And that created a bit of an incentive that really wasn't aligned with the intent of the guideline. And our test was impacted by this, as well as another direct from blood test that's an LDT. And so the guideline was changed that basically if you have a culture that's drawn 2 days before or 1 day after, that's used for your CLABSI determination as it relates to your quality measures. And then you can use the non-culture based test, like a T2 test. And I know someone's taking a picture here, so I'm going to go back for you. There you go. To use for clinical treatment or whatever your clinical use is in the hospital without that kind of pressure. And I think really want to thank the folks at NHSN and CDC for that sort of recognizing, helping pave the way moving forward for these non-culture-based tests and encouraging innovation and use at hospitals. And I think that's a great example. There's a lot of different nuanced things right now that are going on to help address the antimicrobial challenges that we face, and it needs to happen from all over the place in terms of lowering these barriers to solving the problem. Another one of the things that we've encountered is how to use a test like this. We have a great team of MSLs that interface with our customers to say, okay, who do I test? How do I select for patients? Appropriate diagnostic stewardship is an important theme. Blood cultures can be used indiscriminately, and we're finding that by partnering with the hospitals, and we can find these patient populations that benefit the most from the test. And so I wanted to go through a bit of the clinical data that we used with CMS for NTAP, but also give you a picture for the kind of scenarios that these patients are having where they can have a significant clinical benefit from a direct from blood test like the T2 bacteria test. So this is an aggregate of data from 7 different studies that have been ongoing with our technology in the emergency department and in the ICU. And about 300 cases were evaluated, and the T2 positive cases were evaluated to determine, do those patients benefit, what percentage of those patients benefit, and how do they benefit from that T2 positive result. And then a similar story with the T2 negative results. So about 1/3 of the positives, so 28% of the positives benefited from the T2 positive result. And the positivity rate was ranging around 13 to 35%, depending on your patient selection criteria. And then about half of the patients, the negative results, were benefiting from that negative result to de-escalation. What we also found is, we didn't expect this, but we saw a few cases in this study, a couple cases that actually benefited from avoiding earlier discharge or unnecessary discharge and readmission from the emergency department. So I'm going to take you through 5 different cases here to help you get a flavor of this, because a lot of times we find that when people think about a diagnostic like this, they think, I'm already okay. I get the blood culture back fast enough. I don't see why I need this information earlier. Although I think Mary's story is a great example of that, actually getting earlier information could have helped there. Case study number 1 is an anti-pseudomonal De-escalation. So in this case, this T2 bacteria was being used interventionally. A lot of times when hospitals go live, they'll run an interventional study early on to evaluate the cases and the impact of the test. This patient was unresponsive, developed sepsis, and put on a pretty standard cocktail of vancomycin right off the bat. T2 was positive for Staph aureus. That allowed a de-escalation of the piptazone. Why is that important in this patient's case? Well, they're a dialysis patient. There would have been nephrotoxicity that they would have experienced for unnecessary exposure to piptazone longer than they needed to. The next case I'd like to show is one where T2 bacteria was being used interventionally as well. In this case, the patient had aspiration pneumonia. They were started on a cocktail of 3 antibiotics, and the T2 came back positive for club pneumo. They were not appropriately covered for club pneumo at that time. Blood culture was negative. However, they didn't wait for the blood culture. They went ahead and acted on that, put the patient on effective therapy based on their institution's guidelines. It's meropenem, I know. We prefer a different antibiotic for that. But I put on meropenem, and the white blood cell count dropped the next day significantly. After 6 days of treatment, the patient was being able to be discharged from the nursing home. So the institution was really excited about this one. This is an example of a culture-negative sepsis case where patients are going to be able to get caught by a diagnostic like T2 to help get them on effective antibiotic therapy. Case study number 3, in this case, the test was being used by an institution in an observational manner, which is also a common way for institutions to do, where they're collecting the test results and looking to see how it could have impacted the patient care without releasing the result to the patients or to the physicians. In this case, the patient was in the emergency department, came in with an UTI, had symptoms of sepsis as well, fever. They did a urine analysis that was negative. They did take a blood culture in T2, but they discharged the patient. Patient came back the next day because the symptoms had worsened. So they admitted the patient, and then after admission, the culture they had drawn from the previous day came up positive for E. coli, and then in their case review, they found out that T2 bacteria had detected E. coli. If they had loaded that sample right off the bat when the patient was there the first day, they could have avoided an unnecessary discharge. This case here is a bit of a tragic case, a very tragic case. So in this case, the patient had ARDS, was in oncology ICU. They were drawn for culture in T2 on day 0. T2 was positive for faecium. This was an observational use of the test, so the results were not shared with the clinicians. Our faecium specificity is nearly perfect. Any faecium positive, I would urge people to treat on, but of course based on their own institution's guidelines. The patient clinically improved on day 0. They were not on effective therapy for Enterococcus faecium. And then on day 4, they started to decline. Another culture was obtained. That came positive the next day for faecium, but the patient had passed away and was actually never on effective therapy for faecium. I wish this kind of case was not common, but there's a lot of people who are passing away from sepsis and bloodstream infections, and you don't even know what pathogen is infecting them. We can't expect our antibiotics to be effective if we don't know what's infecting our patients when they're acutely ill. We have to fix this problem, and antibiotics are key to that. They're key to diagnostics are key to that, and they're key to enabling the antibiotics' appropriate usage and actually justifying the use of these specialized antibiotics, which today are getting kept away in a locked cabinet because of costs and also because of uncertainty as to whether or not they're truly needed to treat a patient. When you have a diagnostic like this and diagnostic platforms that can go and do this without waiting for culture, I think the paradigm will shift for the favorable outcome of patients. Last case I want to show is more rapid Staph aureus therapy. A lot of times people say, hey, we're covering Staph aureus just fine in our institution. Well, it turns out that first round of antibiotics is based on what we think the patient has, based on the physician's gestalt of what's going on. And certainly that's the best that they have to do today. In this case, the institution was using a patient selection criteria based on lactic acid and procalcitonin. They'd run those tests. It was above a threshold. They'd run T2 bacteria. The Staph aureus positive came out of T2 bacteria 30 hours before the blood culture positive came out. And in this case, the patient was not on an empiric therapy that would appropriately cover for Staph aureus bacteremia. So there's a lot of cases like this out there. We've got to go and find them with the appropriate diagnostics. So I want to transition now and just talk a little bit more about the T2 resistance panel. We're really excited. The clinical cases I've shared you are all based on species ID. And what I hope to be sharing with you in a year from now is clinical cases where interventions or have been evaluated or actually taken using a resistance result from a direct from blood test. Same turnaround time, same sensitivity. It's detecting resistance genes in intact pathogen cells in the patient sample. These are all of your bad actors in terms of known resistance markers for bloodstream infections. There's a lot of excitement about this. We launched this as an RUO test just in September, so 2 months ago. We've got a couple sites already using it here in the US, several in Europe, and we'll have this CE marked by the end of the year to get this into clinical care as soon as we can outside of the US. Some early data there. We have great concordance right now for the T2 resistance panel. Our specificities are sky high, which is essential for this kind of panel. 100% concordance. We've got KPC and CTXM patients already in our studies. We're currently designing a pivotal study that will be in the US for our FDA trial, and really excited about the collaboration with the FDA on how to work on getting this panel out there and how the results might be used. So I think the FDA is doing a great job in helping facilitate new technologies to be shown whether they're safe and effective and get them out in the marketplace. Some of the results that were presented last year on our resistance panel came out of, if you know your Italian geography, those are Italian sites in Perugia and Gemelli. So Klebsiella pneumo, here are all these cases. These are KPC infections. In this study, they're going direct from positive culture to a MALDI. So you have a fairly fast species ID occurring, but then they do their resistance gene typing as well. You get a range of turnaround times. And what I find here in these studies is someone who doesn't want to have new technology will always remember the best case scenario for blood culture. I get my positive cultures back in 6 hours. I don't know why I need a technology like this. And then they don't remember the worst case. In this case, it's 96 hours, which is a little bit longer than 6 hours. And they don't remember actually to calculate the mean and the medians here. So there's a significant lag in these results, especially for resistance genes. So I'm really excited to see how this can impact patient care. I think this kind of panel, and this kind of result direct from blood can really have a positive motivator for these specialized antimicrobials. Because when you know you have an NDM infection, right off the bat, you're going to be able to put the patient on that therapy way earlier, far earlier than you can today when you're waiting for a positive culture. The other panel I want to mention is the panel that is the comprehensive panel. It's in development. We're doing some of this on our own for the fungal targets, and then some work, as I mentioned, with BARDA. We now have de-risked the technology to show that we can be comprehensive. The two channels on here that I think are really novel are the pan-gram positive, pan-gram negative channel. We've seen that on molecular tests for post-culture. But in this case, when you get a result within a few hours and you have a channel that detects over 250 different species of bacteria with an extremely high sensitivity and specificity, then you'll have the option to do some de-escalations that today aren't possible. And so I think that'll do a lot to help address the issue of overuse of antimicrobials. The other panel I think there's a significant need for, and we've been engaged with discussions. There are, as I mentioned, hospitals that are using this panel and stockpiling it for the outbreaks that they're seeing outside of the US. And it's available for RUO and folks to look at and do studies, using this kind of technology for patient surveillance. There's a study in mycoses that Tom Schiller's group did at the CDC. We developed this panel for them because it was taking them 3 weeks to get a positive culture from a patient swab for Candida auris. And with this test, you can get it in 3 hours directly from the patient swab. And so I'm hoping that that kind of technology can help address the problem of colonized patients moving around between facilities and within facilities and causing the spread of this superbug. So that brings me to my conclusion. Just really grateful for the opportunity to share this kind of information with you and be happy to answer any questions. Thank you. Please.
So that was very nice. Thank you. Very interesting. So I'm from George Mason University. Could you just say a little bit more about how you managed to overcome the problem of inhibition with all that blood pudding material that's there? I mean, we've worked with that. It's horrible.
It is. It is horrible. What I'll say is when you have a detector that's completely agnostic to matrix effects, because we forget optical detection and fluorescence and these methods that we typically use have inherent problems with quenching and with other types of absorption and interference. When you have a detector that's completely agnostic to that, these reagents that everyone's using can do a lot of things you don't know they can do, whether it's enzymes, antibodies. And so that's really been the story for us at T2 is taking this detector into different matrices and just saying, I'm not going to be biased by what I believe the reagents can do, because frankly, over millions of years, these enzymes and so forth, they're basically designed to work in complex matrices, but you got to have a detector that can query that in a process that then it can tease that out. And so, yeah, it is a huge challenge, and fortunately, with the T2 detector, we've been able to unlock some of that potential of existing materials. Oh.
Say something real quick about hospital-acquired bloodstream infections, CLABSIs.
Yes.
And what you guys found, because it's actually relevant to all these diagnostics that have come down the pipe, and it solved the problem before it became a problem.
Absolutely, and I'm glad you brought this up, Neil. So Neil's colleague Hong Nguyen at UPMC actually helped lead this. Is any test that's going to be non-culture based test would have run into the categorization of CLABSIs, and then would have led to, in the hospital, people saying, I don't want to, and I actually had an infection control lead at a hospital that will go unnamed tell me, I don't want to identify the infections that I'm missing today. And I was shocked by that. And then it took me a little while to understand what was really being said, is that I don't want to be responsible for driving my CLABSI rates up and losing 1% or more of our annual hospital reimbursement from CMS because within our peer group, we're suddenly out of skew. And that creates, as what I think Dan Deacon said, is a perverse incentive, and that is not what these surveillance guidelines and these quality guidelines are intended to do. And so I think this change that occurred this last year is really important for the field of direct from blood diagnostics so that people can use a test like this without that kind of pressure from administration because there's real financial pressures there, and then prioritize patient care. Now, what's been exciting to me is there have been people, like the folks at UPMC, who have had the courage to say, we're going to prioritize patient care here, we're going to make a case to our administration, and we're going to figure out a way to be able to do this. Fortunately, going forward, that doesn't have to go, and I'm going to get yanked off the stage if I don't stop. So I'm happy to talk to you afterwards. Thanks, Claire.